Hello learners, welcome to this session of Centrifugation. Myself Dr. Arvind Shakya, Faculty of Biochemistry, School of Sciences, IGNOU. Today I will discuss about the centrifugation. This is a topic of the Unit 4 of the Cell Biology course BBCCT 103. This is the course of the BSc Honours Biochemistry program. Let us understand what is centrifugation. Centrifugation is a popular technique that uses centrifugal force for the separation of various biological molecules which are suspended in the liquid medium. The centrifugation uses the centrifugal force to separate off biological particles based on their size, shape and density and rotor speed. So in centrifugation process we use the centrifuge instrument. This is the basic instrument through which we separate of the biological molecules based on their size, shape and density and rotor speed. And during the centrifugation process we applied the centrifugal force by the centrifuge. Now let us understand what is the basic principle of centrifugation. It means what is the basic phenomena behind the separation of the molecules. The basic principle of centrifugation is based on the sedimentation. Sedimentation is the tendency of particles to sediment at the bottom of the tube under the influence of the gravitational force. Gravitational force is a natural force by which the molecules itself sediment according to their size, shape and density. So the higher density particles sediment under influence the gravitational force, but this force does not applicable for rapid separation of smaller biological particles. As we know that cells has many type of organelles and molecules. Cell organelles such as mitochondria, Golgi body, ribosomes, endoplasmic reticulums and so on, and these subcell organelles are tiny. So we need a external force to separate of these molecules or organelles in order to study of their biochemistry. So we use the centrifuge instrument to apply the centrifugal force for the separation of such biological components. So when centrifugal force apply on the biological sample, particles move faster and sediment at the bottom of the centrifuge tube according to their size, mass and density. As we know, the particles differ in their size, mass and density. So the large dense particles move faster as compared to the less dense particles. So the centrifugal force pulls the large particles away from the axis of rotation as compared to the less dense particles. So now consider when a particle moves in a circular motion. What happens during the centrifugation process? Particles move in a circular motion and it experiences two forces, centrifugal force which is outward force and another force which is called the centrifugal force which is towards inverse force, or we can say that it is the force of the which act on the central axis of rotor. So the centrifugal force can be defined as capital G is equal to omega square r. So where omega is the angular velocity of rotation and is that speed of rotation revolution per minute, or omega is equal to 2 pi revolution per minute, and r is the radial distance of the rotating particle from the center of rotation axis. And you can see the slide that when a particle rotates in circular direction, it creates a angle which is called the angular velocity, and its distance between the center of rotation and the axis of the rotation is defined as the r, radial distance. So the centrifugal force is an outward force which pulls the large dense particles for the sedimentation of the molecules. Now we can express the angular velocity in per minute, then omega is equal to 2 pi revolution per minute divide 60. This is equation second, and put value of omega from equation second to equation 1, we get G is equal to 4 pi square r revolution per minute square upon 3600. So this is 3600, it means the 60 1 minute is equal to 60 seconds. So it is multiply of 60 twice, we get the 3600 in equation 3. Now RCF, it is the relative centrifugal force. It is the ratio of applied centrifugal force and the gravitational force. So both forces are acting on the particles during the sedimentation process in centrifuge. So the RCF is often expressed as a multiple of acceleration due to gravity, which expressed as small g. The gravitational force value equal to 981 centimeter square, and so the RCF is equal to alphabet G upon small g. So putting value of capital G from equation third, we get RCF is equal to 4 pi square R revolution per minute whole square upon 3600 multiply 981. Now what is the relative centrifugal field? We discussed before this slide that RCF is a ratio of the applied centrifugal force and the gravitational force. So the RCF is often convenient to express centrifugal force as a value relative to the earth gravitational relative centrifugal force. So we get that RCF is equal to 1.12 multiply 10 to minus 5 rpm square multiply r. So where 1.12 multiply 10 to minus 5 is an empirical factor, r is the radius of rotor from the center of rotation, rpm is the revolution per minute. Therefore RCF is defined as equation fifth, depends on the rpm and the radius of rotation, and it is generally given in units of gravity or multiply g. Now, what is sedimentation coefficient in Swayam unit? The sedimentation rate of particle depends on various factors such as density of medium, density and mass of particle, and partial specific volume and frictional force. When particles move in a circular direction, it experiences the frictional force which is generated by the liquid medium. So frictional force is considered here in the equation. Therefore, as sediment coefficient is the ratio of sedimentation velocity and centrifugal force, it means the S, alphabet S is equal to omega square multiply R upon V equal M 1 minus rho bar V bar rho upon F. So S is a constant for a given particle solvent, and 1 Swayam unit 1S is equal to 1 multiplied 10 to the power minus 13 seconds. So the more the S value means the faster particle will sediment. For instance, ribosome from prokaryotes similar sediment at 70S and their subunits at 50S and 30S. So this sedimentation coefficient is denoted by the Theodore Swayam scientist who got the Nobel Prize in 1926. So the concept of sediment coefficient given by the Swayam scientist who worked on the purification of the hemoglobin, and he also determined the molecular weight of the proteins and colloidal proteins. Now the equation 6 states that the large particles tend to move faster than smaller ones. Denser particles move faster rate than less dense ones. The denser the solution, more slowly the particle will move, and greater the frictional coefficient, the slower the particle will move. It means the large dense particle move faster, or they sediment first as compared to the lesser dense particles. The particles suspended in the solution, if the solution of density is higher, then the particle will move slowly, and the frictional resistance is greater, than means the particles will move slowly. So this is the basic principle of centrifugation. Let us understand what will happen after the centrifugation process. Centrifugation process begins with the separation of the molecules when we put the centrifuge tube containing the test tube of the different size and mass of particles. So these particles are separated under the gravitational force, and we get the two types of fraction, which is called palette and supernatant fraction. pellet is a sedimented fraction and supernatant fraction is a unsedimented fraction. It means the pellet, the fraction contain heavy dense particles and supernatant fraction contain less dense particles. So the pellet fraction is sediment first as compared to the supernatant fraction. So we get here the two types of fraction, pellet and the supernatant. Now come to the instrumentation. What is the main component of centrifuge? There are four components. You can see here in this slide. You can see in this slide there are four components of the centrifuge. Centrifuge is a instrument that used in the centrifugation process. It contains drive shaft, rotor, electric motor, and centrifuge body. So the main component of the centrifuge is the rotor. There are three types of rotor used in the centrifugation process based on their position of tubes relative to the axis of rotation. The rotors are fixed angle rotor, swing bucket rotor, and vertical rotor. The fixed angle rotor, it means the rotor is fixed position. So the sample tubes are placed in openings in the rotor and that are at a fixed angle 14 to 40 degree to the axis of rotation, and the tubes remain in that position during the centrifugation process. The sample tube reorients to the axis of rotation and particles migrate toward the wall of the tube and sediment asymmetrically at the bottom of the tube. So the fixed angle rotor is very useful for differential centrifugation and density gradient centrifugation. The relative distance is maximum at the bottom of the tube and lesser radiance at the bottom of the test tube. This fixed angle rotor contains the tube in a fixed angle of the 14 degree to 40 degree. And another second rotor is the swing bucket rotor. Swing bucket rotor, it swings. When we apply the sample tube in the rotor, it swings. It means at the rest position of the rotor is the vertical position. When we apply the centrifugal force, it becomes in a horizontal position. So in swing bucket rotor, tubes swing out from the vertical to the horizontal position at an angle of 90 degree and relative to the angle of rotation and parallel to the applied centrifugal field. The bucket returns back to the vertical position when centrifugation is completed. So this swing bucket rotor is very useful for the separation of large volume of sample up to 12 liter at low speed, and this rotor is basically used for red zonal centrifugation. And the third rotor is the vertical rotor. Vertical rotor is fixed in vertical position and they are zero angle rotors in which the tubes are aligned vertically in the body of the rotor at all times, and vertical rotors is primarily used for isopaching centrifugation, red zonal centrifugation. What are types of centrifuge? Depending on the rotor speed, rotor types and temperature control, presence of absence of vacuum, there are four types of centrifuge. Number one is the benchtop centrifuge, second microcentrifuge or microfuge, refrigerated centrifuge and ultracentrifuge. So this type of centrifuge are applicable for the different application of the biological samples. The benchtop centrifuge is a low speed centrifuge that can with or without a cooling system, and it is very useful for the separation of blood cells, plasma and serum as well as the cell culture application. So benchtop centrifuge generally used in the clinical investigation for the separation of the blood and serum from the blood components. Second is the microcentrifuge. Microcentrifuge is a mini centrifuge which can be refrigerated or without refrigerated. It involves in separation of a small sample. We can separate the small sample, range is 0.5 to 1.5 ml, and generally in this append drop that contain the small volume sample. So this microcentrifuge can accommodate 24 append drops at a one time, and it can generate up to 15,000 G with or without refrigeration. It is useful for pelleting of nucleic acids and for the concentration of the protein sample. Another centrifuge is the refrigerated centrifuge. It means this centrifuge has refrigerated system. When we increase the high speed in the centrifuge, the centrifuge generate a heat. High heat in the centrifuge can denature of biological sample. So we need a refrigerated centrifuge. Refrigerated centrifuge can generate high centrifugal force up to 60,000 G, and it is widely used for the differential separation of organelles, blood cells and serum. Now, ultracentrifuge is a widely used centrifuge. It is used in the research purpose. It is highly sophisticated instrument which provide the high speed centrifuge, and they are capable of producing high speed and relative centrifugal field of about 2 lakhs G to 6 lakhs G. And there are two types of centrifuge: preparative ultracentrifuge and analytical centrifuge. Preparative ultracentrifuge is widely used for the differential and reactional centrifugation, and the basic component of preparative ultracentrifuge is the speed control panel, temperature control panel, vacuum system, rotor and the cooling system. So for safety reason, the rotor chamber is completely enclosed in a evacuated heavy armored chamber, and the preparative ultracentrifuge generally used for the differential and density gradient centrifugation for separation of the biological components from the liquid biological sample. And second is the analytical ultracentrifuge. The basic component of analytical centrifuge is similar to the preparative ultracentrifuge, except that it is equipped with an optical system. It generates centrifugal speed at 60,000 rpm and RCF of 6 lakh G. An analytical centrifuge is useful for determination of sediment coefficient, molecular weight of macromolecules such as DNA, and conformational changes in protein structure. So in analytical ultracentrifuge, we use the light source which monitor the separation of molecules, and it is very useful to continue monitor of the separation of molecules. So this type of analytical centrifuge. Now we understand what are the precautions in the centrifugation process. As we know that centrifuge is an instrument, so we need to some precaution while performing the centrifugation process. First, read the manufacturer manual carefully before using the centrifuge. Ensure that sample tubes are evenly balanced with reference tube, especially when working with high speed centrifuge. It means when we put the centrifuge tube in the rotor, then we also put the same reference tube for balancing of the rotor. If we do not the balancing of rotor, it means it will create some problem during the centrifugation process. And do not open a centrifuge lid during rotation. Do not touch the rotor in motion. Rotor speed should not exceed the assigned speed, and rotors and centrifuges should be kept clean and dry during storage. Wear a lab coat and face shield or safety goggles while working in the laboratory. So these are basic precautions we have to follow during the separation process, and these are the things that we must follow during the separation of biological samples in the centrifuge. Now, what we learned is that the centrifugation is a modern technique used in the separation and purification of cellular components and biological objects. Particles separate due to their differences in size, shape and density under the influence of applied centrifugal force. The sedimentation coefficient is a constant to define the sedimentation rate of a particle, and it is the ratio of sedimentation velocity v and centrifugal force g. It is generally expressed in Swedberg unit, which is equal to 1 multiplied 10 to minus 13 seconds. The main components of centrifuge instrument is the rotor. Rotor is the main component, which is a rotating units. It means it rotates the sample molecules in a circular direction that sediment according to their size, shape and density. And the rotor produces a centrifugal force on particles to be separated, and three types of rotor are fixed angle, swing bucket and vertical. rotors. So these type of rotors are very useful for different application, and we understood the four types of centrifuge, which is bench top, microcentrifuge, refrigerator centrifuge, and ultra centrifuge. These different types of centrifuge use the different application because they produce different type of speeds based on their rotor speed and different application. Every user should familiarize themselves with the basic safety measures and maintenance of centrifuge. So this topic on the centrifugation is a separation technique which is widely used in biochemistry and molecular biology. And B, by understanding the basic principle and application of centrifugation, we can separate the molecules of cells or biological objects using the centrifuge device. And these are the some suggested readings for study of the centrifugation topic. I hope you understood this session of centrifugation. You can refer the study material of BBCT 103 Unit 4 for further study of this topic, centrifugation. Thank you, learners.